So far, we have focused on the case of an oligopoly with two firms in order to bring out a lot of the notions, concepts, and tools. But really, a very important question is what happens in an oligopoly equilibrium as the number of firms goes up. So what happens as F increases? Now, what we're going to do here is we're going to look at a case with more than two firms, F greater than 2, and we're going to keep it simple by assuming that we are in this linear symmetric case that we studied before, which basically says that the inverse aggregate demand function is just P max minus MQ when Q is the total quantity produced, and that every firm has a marginal cost that is constant and equals to mu. Now, let's characterize the equilibrium of this oligopoly market. Okay? It's actually very, very easy if we use the same key insight that we used before, which is that because all of the firms are identical, we're going to get a symmetric equilibrium in which Qi at the oligopoly is going to be equal to Qj at the oligopoly. This is the quantity produced in the oligopolistic equilibrium by firm I or by firm J, and I'm going to denote just the quantity produced in equilibrium by any firm by QOL. Now, how we would derive that property? We know that the demand phase by firm I is just going to be equals to P max minus F minus 1 M QOL, because that is in equilibrium the quantity produced by all of the other firms except firm I that we're looking at, given that they are producing at the equilibrium level, minus MQI. Now, given this, we know that the optimal behavior, optimal choice by I, which as before takes the behavior of the other firms as given, it sets marginal revenue for I equals marginal cost for I. The marginal revenue for I is going to be P max minus F minus 1 MQOL minus 2M QI equals the marginal cost, which is mu. And since this has to be the same for every firm, we can assume that this is QOL too. And that implies, just solving the equation, that QOL is equal to P max minus mu of F plus 1 M. Notice that this is the quantity per firm in equilibrium. It's not the total quantity. The total quantity is F times this. Now, we also can derive what is the price in equilibrium by substituting the total quantity here, and we're going to get that the price of the oligopoly in equilibrium is going to be equal to P max minus M times this quantity, which is just going to be equal minus P max minus mu F over F plus 1, and this is just equal to 1 over F plus 1 of P max plus F over F plus 1 of mu. Okay. Notice one interesting thing. We know that in a competitive equilibrium, we saw that before, the equilibrium price is mu, and here what we have is a weighted combination of this larger number P max and mu, but as F increases, the weight shifts more and more and more and more to mu, so it converges to the competitive equilibrium as F goes up. Now, given those results, we can easily compute what is the deadweight loss as a function of the number of firms F. Okay? What we're going to get is 1/2 of what is the price in oligopoly we just derived as a function of F minus the price in competitive equilibrium. And by the way, remember, we know that in competitive equilibrium, this is mu, which seen that repeatedly this unit, and the difference in the quality produced in the oligopoly minus the quantity produced in competitive equilibrium. And again, as we saw before, remember, this is equal to P max minus mu divided by M, or the optimal amount. If you do the algebra, this gives you 1/2 of P max minus mu divided of F plus 1, and P max minus mu divided by M times F plus 1. And this is equal to 1/2M P max minus mu square divided by F plus 1 square. And I want to emphasize this result. I think this is a very remarkable result because it's telling you something extremely beautiful and extremely important, which is that the deadweight loss goes to 0. In other words, you are converging to the efficient allocation, to the competitive equilibrium allocation with the square of the number of firms. Not linearly, but with the square. That means, for example, that by the time you have 10 firms in there, you are approximately within 1% of achieving all of the efficiency gains. It's noise. And that is very important because it's telling us that you don't need to have a very large number of firms, which there are not in most markets, to really have the competitive model be a good approximation of what happens.